Hello everyone, welcome to this second day of SolidCAM World presentation. So the first presentation today is about a powerful SolidCAM demo. And indeed, demonstration is a very important topic in order to show all the power of SolidCAM in order to close deals in a fast and sure way. So let me first introduce myself. So my name is Herve Philibien. I'm area manager for SolidCAM France. I started to work for SolidCAM France 14 years ago. At this time I was student, and I indeed spent 2 months in SolidCAM Limited with development and QA team. So it's a really pleasure for me to come back a few years later as a presenter today. After my studies, I started to work for SolidCAM France as an application engineer. So I was in charge of technical support, customer training, and post-processor development. So I spent a lot of time with customers side by side, and I learned a lot from them about their manufacturing process, about their needs, about their expectation, about manufacturing and CAD/CAM capability. And then in 2019, I became area manager for east part of France, so east and southeast, and also French-speaking part of Switzerland. So my main mission is to develop and leverage SolidCAM France activities and business. So I do a lot of demonstration to potential customers to increase our customer number. So today I will do one more demonstration, but this time to you. So let's start. For the people that don't know at all SolidCAM and that discover SolidCAM for the first time, I will give you a quick and comprehensive idea of all SolidCAM advantages. So the first thing that I want to do is opening an existing CAM project and give you a complete overview of SolidCAM. So the part that I will open is actually the part done by SolidCAM UK, the leaf part done with the Mazak. So the first thing that I want to explain is that SolidCAM is not just a CAM system. We are not just a CAM system. We are a CAD/CAM integrated solution. And this small difference in word between a CAM and a CAD/CAM integrated solution is a huge difference in CAM programming, in manufacturing process for a company. So we have to explain and insist about the difference between a lot of CAM solution, competitor CAM solution, and SolidCAM, which is the leader of CAM integrated solution. So let's switch to SolidCAM. I will, yeah. So as you can, no, you don't see it. So yeah, so as you can see, everything in SolidCAM is running into SolidWorks, into the CAD software in which we are integrated. So for my demonstration, I will do everything in SolidWorks, but we are also integrated in Autodesk Inventor. And the first thing that people need to know about SolidCAM is that we benefit of the best CAD features for CAD, and also the best feature for CAM. And just in order to switch between CAD and CAM, we just have to switch between these two small tabs right here. So we can switch from CAD Tree Manager to CAM Tree Manager, just like this. And also in SolidWorks, you have what is called the ribbon. So you can just switch from assembly CAD feature, for example, sketch feature, to SolidCAM feature. So every machinist need CAD capabilities. It's like that. And in order to be efficient in CAM programming, you need efficient CAD feature. So this is our differentiator, and it's really important to get powerful CAD feature. Emil said yesterday that the integration is also very strategical because it allows SolidCAM to be 100% focused in development on CAM feature. So this is also the promise and the guarantee to our users to get the best CAD features and the best CAM feature. Okay, so let's see the environment inside SolidCAM. So inside the CAM tree manager, you will get everything, every information, every data inside. So the machine, the coordinate system, the stock, the target, everything is here. The same as the tool libraries, and all the operations that you will create will appear one after one in the CAM tree, like here. And while defining your machining process, you will be able to add some 2.5 operation for prismatical machining, 3D machining for 3D shape, multi-axis machining for 4 and 5 axis simultaneous, as well as turning. And once your programmation will be finished, you will have access to also the best simulation, which is a Swiss 64 bits architecture, build architecture, supporting the latest hardware technology with multi-core processor. And in this simulation, of course, you will be able to detect any collision, to simulate every part of your machinings. So you will be also able to see cycle time and all you need. So what we see here is a roofing, and a roofing done with the pattern den and revolutionary eye machining. So we heard a lot about it, and we need to remember that the eye machining is what brings SolidCAM user and customers cycle time reducing, thanks to the ability to generate constant cutting angle. So we get constant cutting force, and it allows to take very deep step down. And once we do the eye machining 3D roofing, we will have also access to some 5-axis simultaneous operation. So the roofing is almost done, and then we will get some some 3D milling and some 5-axis operation. And these 5-axis operations are also done with cycle end mills, which allow to generate also some cycle time reducing and better finishing qualities for finishing strategy. So I don't need to simulate. I just want to give you the overview of SolidCAM. And of course, when you have generate all of this, we have also what is called machine simulation. And in machine simulation, you will be able to see all the kinematic of your machine. You will be able to see all the machine environment to check that machine don't reach the limits, that there is no collision between some element of the machine, etc., etc. Okay. The last step, once you validate your process and simulate it, of course you can check if there is no rest material, if you didn't machining too much, in order to be sure that the part that you will obtain on the real machine is correct. You will be able to generate some manufacturing documentation with all the list of tools, with all the list of operation. This is customizable. We have online web configurator, which is one of the what's new of SolidCAM 2022. So this is important for good communication between CAM programming and shop floor and machinist operators. So I generated for all the operation just to give you an idea. And this is what you will get with the tool list. So every information inside, and you will be also have the ability to get some screenshot of the setups and where is the coordinate system is located, etc., etc. And the last things also that is very important is to generate a G-code, because at the end, what is important is to run the machine. So I want to insist a little bit about that, because this is maybe the most important part of a CAM system. A CAM system without good post-processor is worthless. And that's where also SolidCAM is a very appropriate solution, because we have, so I will just switch back on my presentation. That's where SolidCAM also is particular, because we have a very strong and very large Reseller networks. And this allows us to deliver you the guarantee and the promise that we will running your machine. And this is very important. So I choose this particular project because it's a real project machined by SolidCAM UK. And you saw yesterday, and all the video is also available online, the real machining on the machine. So we just don't promote e-machining and cycle time reducing. It's real, and you can see it on the machine. And as I said, the G-code that you will generate, so I said few words also about cycle segment tools in order to generate cycle time reducing on finishing. So you will get also additional information in Hammond presentation on 5-axis simultaneous. And as I said, one of the most important parts in CAM is the post-processor. And because of the large network, we have behind us a huge post-processor database with local high qualified and skilled teams all around the world. And this is also a differentiator of SolidCAM. And when we see this assembly, we can believe that SolidCAM is really in capacity to run any machine around the world. Okay, so now I want to start a demonstration from zero. So we will just use a small part, a medical component. I will show you. Yeah, I need to switch every time. Okay, so this is, I will show you the part that I will use. But first, I want to say one word about CAD data. So This is the part that I will program from zero, just to show you. And this 3D model that you will get you can receive it in several formats. It can be a neutral format, so STEP, EGES, and in this case, you will need direct editing CAD feature, because the part that we have in 3D here is generally a little bit different than the part that you need to machine in a real, because of tolerance machinings. So you need some powerful CAD feature. And the good news is that SolidWorks has 3D model direct editing. You can also receive different CAD native format from a different CAD software. And also, SolidWorks and Autodesk Inventor has feature to open different native CAD format. And the last case that you can meet is to receive a 3D model in native format from your CAD software, from SolidWorks or from Autodesk Inventor. And you can need also to manage CAD revision. So the 3D model can come also from a PDM. So in this case, you will be able to work on native CAD file, and you will be able to work directly from CAD PDM. So these are real advantages for CAD/CAM programmers, because you get already everything inside. So let's start my programmation. First step, we open the 3D model. Then we start a machining project. So I will start a mill-turn project. We will define the coordinate system, and we will choose the machine on which we want to work. So my coordinate system will be on the top of the 3D model. I just click a cylinder face. I can create several coordinate systems, so I will create a second coordinate system at the back of my part. Just add a second one. And this time I will switch to the opposite at the back of the part. And you can see SolidCAM all automatically define and recognize the target. It also defined a torque with some extra material regarding my settings. I can change it, of course, from one project to another. I will define also the material that I want to machine. So I will just use titanium, and then we can start to create some operation. So what I will do is turning operation. I will just make a face. So this simple part has a circular shape in top of them. So the first thing that I will do is using wireframe just to ask a face on this geometry, and I have the ability to just shift it in order to reach the final shape of the part. I take a tool, so you can start from an existing tool library, of course. What is important also is that you will get the tool preview, so you can manage, thanks to Toolkit, which is a very powerful tooling library. You can assemble some holders with turning inserts. When I select it, you can also manage your cutting condition, and as you see, it automatically switches to the cutting condition defined by the machining material, and then, okay, you apply your technology. So I just make a face, just like this. I will just the external turning, so this is the same. Just keep it. So this time I work on solid. I will come from here to here. I will apply a small extension. Okay? And you see, this is tangential extension. So I can just quickly apply an angle. I can select again a tool. So I will reuse the same tool. And as you see, we are also in a mill-turn machine. So I can switch easily to some additional angle or change the orientation of my tool because my machine has a B-axis capabilities. I will also do roofing with finishing, and that's it. I create my operation. What I want also to talk about is the setup and the machine preview that we have right here. The machine preview is a very powerful feature because it will allow you to define how much you want to put the part out of the spindle. So as you see, I can change the value and see directly what it will done. And my machine, this one, the Vilma Macodel 408 MT has a retaking unit. So I can define the same how much I want to make outside the part from the retaking unit. So I will just use, sorry. I did a new position instead of a new coordinate system, so I will just change that. Okay. So that's it. So yeah, in my setup, I can use my second origin, and I can see my part in the retaking unit, and how much I want to just put it out. Okay, let's continue. Then I will just do some small milling operation after the turning, and what I wanted to show you is the machine preview about the B-axis. So as you can see, if I define additional angle, just to show you, you see directly the B-axis of your machine. Okay, so let's continue with milling operation. I will just make a small profile operation. I will ask to do, for example, the profile of this, just like this, with maybe some approach. I will select a tool. I will take this tool. I will define the depth. Okay. And sorry. Sorry. Yeah, of course. I forget my position. So I will create one position, and my position I will create it on the same position as the position 1, and I will change to the opposite. Okay. So once I create my position, I define my geometry. So I just want to make one profile job on this, and just like this, I get a small profile operation. Okay, I will just redefine my depth correctly, and that's it. What is important also is that you will have access to small transformation. So you can apply, for example, a mirror just to get the same on the opposite side. And of course, SolidCAM will keep the conventional and opposite direction. What I will do then is the milling operation right here. So I will just add this time eye machining operation. I will again create a position to index my part. I will work on this direction just by clicking this face, and I will define my geometry. So thanks to feature recognition, I will define this shape over here. And here, if you don't have a CAD-CAM integrated solution, it can be maybe difficult because you will have to select all this geometry. And what is interesting is that SolidCAM gives you the ability to reach the sketch directly in the design model. So you can come and find the sketch that was used to draw the part and use it for defining your geometry in CAM. So this is also an advantage of CAD-CAM integration. So I will just yeah, sorry, just show it like this. I will just select my geometry and I apply a tangent extension. So you see we get the chain. I will just reverse it. I select again a tool. So I will take my tool with 3 millimeters diameters. I will select a second tool in order to do a rest roofing operation, and I will ask to apply finish operation. I will define my depth, and as you can see, okay. As you can see, SolidCAM detects automatically the material that need to be removed, and then you calculate. I will just change the order, just like this. And if we simulate just this few operations, you can see easily the start of your programmation. Of course, we can manage to go straight here. We can change the full depth, etc., etc. And what is important once you did that is the transfer and the use of the rotating unit. So in SolidCAM, we have what we call the MCO that allow you to program external equipment of your machine. But the transfer is something recurrent. It's always the same. I come with the rotating unit, I clamp the part, I cut off, then I move back, and I switch to vertical position. So this, in SolidCAM, can be saved in a template. And what is nice is that you can save your templates, and you can just drag and drop like this and import your full transfer process. So as you can see here, I can just select my cutoff tool, pre-positioning at the back of my part for cutoff, then come with my retaking unit in a safety position, in approach, in rapid, came in a feed at the clamping position, and then I can just cut off my part. So I just have to select this geometry, just to cut off the back of my part. My tool is already selected in my template, and I will just apply an extension. That's it. And just like this, I get all my transfer done. And then, because I'm on this particular machine, I have one operation to come back with the part and just come back the retaking unit in horizontal position, and I will be able to work on the back of my part. So what I can do also is what we talk about it a lot, because we are integrated in CAD, again, is the ability to apply automatical process for drilling. So I can drag a process, for example, to this hole, and automatically it creates my operation. It selects a tool, okay? Just by drag and drop. I can do the same for the small hole over here. So again, I drag to this hole. And just like this, I get quickly my full programmation, okay? The first step, as I said, is to generate the J-code, because this is the most important part. And again, because we have a worldwide network, we can deliver the post-processor in English, in French, for French user, but as well in German, etc., etc. So we have the capability to customize the post-processor. And this is very important. So if I come back to my presentation, I just want, oh, sorry. This one. So we made the full programmation of this part. Also, we can simulate the machine simulation environment. Of course, I should have shown, but you will get the full machine. And what is important, as I said, is to drive the machine. So in this case, it was a project, and we collaborate with SolidCAM UK, with Mark Stokes, with Marcus Roth from Switzerland as well, and SolidCAM France also. And at the end, it's our customers that are happy to get not only a very good CAD and CAB system, but also a dedicated post-processor and a proven post-processor to be sure to get the ability to drive their machine. I just want to open, yep.
Powerful demonstration, but I have a question.
Yep.
After the end of your standard demonstration, sometimes the customer will probably give you a model and say, okay, program mine. How many percentage of your demonstration you do also a customer part?
I do almost only customer demonstration on customer part. Almost only.
After your standard demonstration?
Actually, this one that I'm doing right here is kind of customer part. This is not exactly a customer part. I modified it, but this is typically a part that I could receive from a customer. So generally, I just open the project as I show you, just to give an overview, and then I program directly to customer part.
So the first half you do it standard, and then what you did for programming, you do it on the part of the customer.
Exactly, of the customer. Because generally, if you get asked about a demonstration, it means that the people that you have in front of you want you to prove something. So it's either that SolidCAM is a better CAM solution than the existing CAM solution, so you have to prove the feature capabilities of the software, or you have to prove that you will be able to machine the part for real, so in the software and also on the machine. That's what I want to insist about post-processor, because that's what makes the difference at the end, not only in the software, but also on the real machine. So again, this is a kind of customer part. It's just a ring. And the advantage also of CAD-CAM integration is the CAD-CAM associativity. It means that if a change is done in CAD, all the CAM process can be updated regarding the change of the CAD. So as human is different from one to other, we need a lot of size of ring for the size of the finger. So my small part here, so I can show you just quickly the operation. If I switch from small size to big size, just like this, and I switch back in SolidCAM, I get some spotlight. And just by asking to synchronize, all my toolpaths and CAM programming will be updated. So the integration is not gadget. You started yesterday by saying associativity is important. It is. This is the added value of SolidCAM. We are not just a CAM. We are the best CAD-CAM integrated solution. And you have to insist on that. Because if you deliver the associativity, any other CAM, they cannot. So that's how you can convince your customer that SolidCAM is the best solution for them.
Excellent. Convinced? Give him your hand. Thank you.
Thank you very much for your attention.